So this week, I'm going to be focusing on theoretical, actual, and percent yield. So I'm going to go straight into calculations, and I'll show you an example of a full-out calculation of how to find your theoretical, actual, and your percent yield. Okay, so the question for my theoretical, actual, and percentage yield is this. So NH3 is ammonium, okay, plus carbon dioxide gives you urea plus water, okay? And the question is that a typical starting reaction has a 3 to 1 ratio of NH3 to CO2. Now, if 47.7 grams of urea form per mole of CO2 that reacts, what is the theoretical, actual, and percent yield? Now, for starters, for actual yield, you don't have to do anything, okay? For actual yield, it already gives you that in the question, which is your 47.7 grams of urea for every mole of carbon dioxide that's reacting. So we've already determined that my actual yield is 47.7 grams. So from the question, we find out that the actual yield is 47.7 grams of urea for every mole of carbon dioxide that reacts. Okay? Now, the next thing that we have to find is the theoretical yield. Now, this is normally harder to do. Okay, so you guys probably remember, or you guys could go back in the video to find out what the balance equation was. But you find that the mole-to-mole ratio between the urea and the carbon dioxide is a 1-to-1 mole ratio. So first thing we have to do is find the moles of urea from the moles of carbon dioxide. How you do this is you know you have 1 mole of carbon dioxide that reacts because you find out that your actual is as a factor of 1 mole of carbon dioxide that reacts. So this is going to be equal to 1 mole of CO2, which has reacted, times 1 mole of urea that forms, per 1 mole of CO2 reacted, and that gives you the number of moles of urea, which 1 times 1 over 1 is 1. Okay. So next what you have to do is take these moles and change them to grams of urea by using what we know as molecular mass, which you can get that very easily from a periodic table. I'll just give it to you. So the molar mass, which is mm for short, of urea is 60.1 grams per mole. Which, once again, it's a simple conversion. So to find out what my grams of urea are, I just have to do this 1 mole of urea that I had times my molar mass, which is going to be 60.1 grams per 1 mole of urea, which 1 times 60.1 times 1 is just 60.1. And you can see that my units cancel out, so I'm just left with grams of urea. So once you do this, once you have your grams of urea, that is your theoretical yield in a number of steps. Okay? Now, there's another way of calculating it, which is just taking these individual steps and just putting them together to get this final answer in one line. But as you can see now, your theoretical yield, this is what this becomes, is the 60.1 grams. So let's have a quick recap. So my actual was gotten from the question, which was 47.7 grams of urea. For my theoretical, it came to 60.1 grams, once again of urea. So my percent yield is equal to my actual yield over my theoretical times 100. Which in this case is equal to 47.7 grams divided by 60.1 grams times 100% equals, so this equals 79.4%. And this, my friends, is how you find your actual, theoretical, and percent yields. Subscribe to me so you guys can see some cool videos doing science and experiments and maybe learning something new. Thanks!